I said before that our basic functions give us entire families of functions. We're going to begin to see how that works. If we start with our basic y equals x squared function, as we've seen, we could stretch that function by a factor of 2 to get the y equals 2x squared function. That stretching means that we take every point of the y equals x squared axis, x squared graph, the y equals x squared graph, we take every point of that graph, we determine its distance from the x-axis. We could sketch a series of points and sketch a distance from the x-axis. And then we indicate that distance by an arrow, and we make an arrow twice as long, and that gives us a point on the vertically stretched function, the doubled function, the y equals 2x squared function in this case. So for every point we draw an arrow from the t-axis, I think I said y-axis a minute ago, or the x-axis, up to the graph, and then we draw an arrow of double that length up to the graph of our doubled function. And this is what we mean when we say we vertically stretch the graph of a function. We can vertically stretch by a factor of 1/2. We take every point here and we move it to 1/2 as far from the x-axis. That's going to actually compress the function. Our graph of y equals 1/2 x squared corresponding to taking this point and going half as high, this point going half as high. Of course the vertex is at 0 and half of that is still 0, so that's going to remain where it is. You see that we're going to get a graph that looks something like this. If we did y equals negative x squared, then we would take each point, the distance of each point above the axis, and that would become a distance below because we're multiplying by a negative. Again, when we double the y coordinate of y equals x squared, that doubles our y, so in order to get double the value of y, we've got to compute y equals 2x squared. So we have the graph of y equals 2x squared when we double the y coordinates of the y equals x squared graph. If we triple it, we'd have y equals 3x squared, 1/2 the height, 1/2 x squared, as we've seen.